So good afternoon guys. So yesterday we have talked about this thermal properties of matter, right? So we were in the topic that is so thermal expansion. So we were discussing about the thermal expansion. In that we were discussing the linear expansion, areal expansion and the volume expansion. So let us see once again what is the three things and then we will go for the next topic, right? So the thing is, first one it is linear expansion. Second one, areal expansion, and the last one it is volume expansion. So basically when we talk about these three things, so one is one dimensional, second one is two dimensional, and third one is a three dimensional, 1D, 2D and 3D. So when we talk about the formula point of view, delta L by L will be equals to alpha delta T, right? So when the change in length is happening, it is due to the temperature change. So delta L by L is directly proportional. Delta L by L is directly proportional to delta T. So to remove that proportionality, we are adding a constant called alpha, which is nothing but coefficient of linear expansion. So similarly, delta A by A is nothing but beta delta T, and delta V by V is nothing but gamma delta T. And I have given the relation between these three things, alpha, beta and gamma. So alpha is equals to beta by 2 is equals to gamma by 3. So this is the relation. Got it? Okay. So next we will go for the topic thermal stress. So what happens by preventing the thermal expansion of a rod by fixing its end rigidly? So in the previous cases what we have done is, the free end was like there was a free end. Right now when I give a heat or temperature is raised for the given object, what happens? It expands. But in this case what we are doing is, we are preventing the end, we are fixing the end. Okay, now we are heating the substance, like we are heating the object. Now what is the thing is going to happen here? So the rod acquires a compressive strain due to the external force, provided by the rigid support at the end. Okay, so it takes the compressive strain, okay, and it is due to external forces. Got it? So the corresponding stress set up in the rod is called as thermal stress. Okay, so compressive strain in the sense like, it is fixed weight, it is not expanding right now, so that's why it's a compressive strain, and this corresponding stress is there. No, that stress is called as thermal stress. Got it? Okay, we'll go for the next one. So here is the application point of view. So to solve the equations, so the first one is variation of time period of a pendulum clock. Okay, so what happens here is, like in the pendulum clock, no, like one side of the pendulum, that a length is there, no, it has been fixed. So what happens there? So the time represented by the clock hands of a pendulum clocks depends on the number of oscillation, right? Number of oscillation which is performed by the pendulum. Every time it reaches the extreme position, the second hands of a clock advances by 1 second. So there is a pendulum clock, when it reaches the extreme position, no, either right side or left side, it goes for the next second. Okay, So we know that the formula is T is equals to 2 pi root over L by G. Root over L by G. Now if we raise the temperature, what happens here? T dash will be equals to 2 pi root over L by G. So here L naught we have taken like initial length. Initial length. So what is the thing independent over here? Yes, 2 pi is constant, but the thing is G is independent, right? So G doesn't change if temperature decreases or increases. G will be as it is. Okay, so this is at initial temperature. At initial temperature, and T dash it's by eating or by giving some temperature. Okay, final temperature will tell. So when we talk about the initial and the final, no, we are taking the ratios of both of them. So ratios in the sense T dash is final and T is initial right now, and the 2 pi and root G will get cancel each other. So the remaining terms will be root over L dash by L. Got it? So what is L dash? So change in length, right? Change in length divided by L. Delta L by L will be equals to alpha delta T. Right now alpha delta T. So that's the formula we are going to use here. So root over L times of 1 plus alpha delta T divided by L. Okay. So this L and this L will get cancelled. And if you notice here, we are writing this root over 1 plus alpha delta T. Okay. I'll keep as it is this one. So 1 plus alpha delta T I can root over, I can rewrite as power 1 by 2. Power 1 by 2. So we have talked about this case in units and dimension, that first lesson, right now. So binomial approximation method. Binomial approximation method. Okay. And we'll take the power and we'll multiply in front of them, right? So x power n, if x is less than 1, very less than 1, for example it's a 0.001, okay, when I square this also I will get a very small term only, a small number, because the value which is given itself very small, right? Okay, so for that what we are doing, we are reconsidering this as nx, n into x. Got it? So therefore change or loss, change, that is loss or gain in time period, that is taken as T dash by T. So T dash minus T by T will be equal to of alpha delta T. Got it? Yeah, you can take a note of this. So based on this formula, they might ask question. So in previous examinations in EAPCET, we have got these kind of questions. What is the change in time if the temperature has been increased? Got it? Okay. So if you listen here, gain or loss in time during, it is nothing but delta T is equal to of alpha delta theta. So delta theta is nothing but its change in temperature. And we are taking this T in the other side, that's it. Okay. Now whatever formula we have discussed here, we are rewriting that formula. And note point, if T is the correct time, then if theta is less than theta naught, okay. So theta naught is the initial temperature and theta is the given temperature right now. T dash will be less than T. So clock becomes faster and gain time. Okay. And if theta is greater than delta T, okay, I mean theta naught. So what happens here, because of the temperature increases, no, like the length also increases, So T dash will be greater than T, clock becomes slow and loses time. So if you keep remember these 2 points, okay, theta is less than theta naught or theta is greater than theta naught, it becomes fast and gain time, becomes slow and loses time. Got it? Yeah. So we'll see the question over here. Yeah. So estimate the time lost or gained by the pendulum clock at the end of a week when the atmospheric temperature rises to 40 degrees Celsius. The clock is known to give correct time at 15 degrees Celsius, right. So and the pendulum is of steel. So which is given as the linear expansion is given as 12 into 10 power minus 6 per degree Celsius. Okay. So this is the given question. So we can give answer. So there is a solid 1 minute time to solve this question. So whatever the formula which we have seen in the previous slide, the same formula and the same concept which we are going to use in this question too. Okay. You can read the question once again and we have a solid 1 minute time to give the answer of this question. So 30 seconds left. Okay. So we'll see the answer of this question now. So when we talk about the rise in temperature now, so rise in temperature gives the change in temperature. So initial temperature was 40 and the rise in temperature, I mean initial was 15 and the rise in temperature was 40, right. So the change in temperature is 25 degrees Celsius, right. And when we talk about the formula, T, I mean delta T by T will be equals to minus 1 by 2 delta L by L, right. So time lost per second, the formula is of alpha delta theta. Okay, this is delta theta, right. This is delta theta. Got it? So half into alpha, what is the value of alpha? The value of linear expansion, coefficient of linear expansion is alpha. So it is 12 into 10 power minus 6 and value of delta theta is 25. So when we multiply the values, we will get 150 into 10 power minus 6, okay, 150 into 10 power minus 6. So therefore the time lost per week they are asking, no. So lost per week in the sense I need to calculate the seconds, how many seconds for a week. So 7 into 86,400, okay, 86,400. So per day 86,400 seconds, got it. So into 7 days, so we will get 150 into 10 power minus 6 and times of 7 into 86,400. So we will get around 90.72. Okay, you will get around 90 or 91, both okay. 91 is the answer. 91 seconds is the answer of this question. Okay, then we'll go for the next one. So the next topic is bimetallic strip. Bimetallic strip. So bimetallic strip, the meaning itself tells that, like the word itself tells that it's a two metals, okay, two different metals we are adding, like we are stripping together. So a bimetallic strip is made from two thin strips of metal that have different coefficient of linear expansion. Okay, I will give the figure over here. Okay, so the figure will be looking like this. The figure is missing over here. Okay, let me take this as A1 and this as A2. So A1 and A2 are the two different materials which is having two different linear expansion, coefficient of linear expansion. So a bimetallic strip on, like, okay, bimetallic strip is heated and then cooled. The things we, yeah, the image is missing. Leave about this thing. Okay, so brass, if you talk about brass, the value of coefficient of linear expansion is 19 into 10 power minus 6 and the steel it is 12 into 10 power minus 6. Okay, so two pieces are welded and riveted together. Riveted in the sense they have joined together. Okay, when the bimetallic strip is heated, the brass having the larger value of alpha expands more than the steel. So when alpha value is more, the expansion also more, delta L by L. So delta L is more. Okay, if alpha value is less, delta L also will be less, because when we talk about in the term of formula, delta L by L is directly proportional to delta T and delta L by L is equals to alpha delta T. So alpha increases, delta L increases, alpha decreases, delta L also decreases. So since two metals are bonded together, the bimetallic strips bend into an arc shape. Okay, so what happens, this one increases more and this one is increased less than the A1. So it will convert into a circular part. So it will be looking like this. So this is A1 and this is A2. And when we talk about this A1 and A2, both are having a different radius, right? So from this point, center point to A2 will be having some radius, and from center point to A1 will be different radius. Both will be having a different radius because the A1 increases more and the A2 increases less than the A1. Got it? When the strip is cooled, the bimetallic strip bends in the opposite direction. So when we are heating, it will be in this direction. Okay, suppose if they have given in this direction, if they cool, in which direction it will change? in the opposite direction. It will be changing like this. Okay. So this is about the bimetallic strip concept. Done? Okay. So, yeah, we'll go for the next one. Yeah. If expansion is isotropic, okay, then expansion area will be taken as 2 alpha and expansion in volume will be taken as 3 alpha. Here's the same concept which we have discussed in the relation between alpha, beta and gamma. So alpha is equals to beta by 2 will be equals to gamma by 3. So beta will be 2 alpha and gamma will be 3 alpha, right now. So the thing when they mention expansion in isotropic, okay, expansion in isotropic. So linear expansion coefficient is alpha, areal 2 alpha, volumetric 3 alpha. Yeah. So we will solve now some questions. Yeah, I guess the question is visible. Consider a steel rail of a length 5 meter and area of cross section it is 40 centimeter square that is prevented from expanding while the temperature rises by 10 degrees Celsius. Okay, temperature has been raised by 10 degrees Celsius. The coefficient of linear expansion of steel is given as 1.2 into 10 power minus 5 Kelvin inverse, and Young's modulus of steel has been given as 2 times of 10 power minus 11, 10 power 11 Newton per meter square. Okay. So what is the thing they are asking? Yes, find it first. So consider a steel of a rail length they have given that is prevented from expanding while the temperature rises. The coefficient of linear expansion is given and y is given. So first try to write the given terms. Okay. So they have given length is equals to 5 meter and change like rise in temperature they have given it is 10 degrees Celsius. And alpha it is 1.2 times 1.2 into 10 power minus 5 and Young's modulus y is equals to 2 times of 10 power 11. Okay, and one more thing, area of cross section they have given as 40 centimeter square. So try to convert everything into SI units. So 40 centimeter square in the sense 40 into 10 power minus 4 meter. Got it? Now you need to calculate it. So because 5 is in meter, area is in centimeter, okay, and everything is in SI unit. This one is in CGS, so try to convert it, and when we are converting it is 40 into 10 power minus 4, right? So we have a solid 1 minute time for this question to give answer. Done? Okay. Let's see the answer of this question. So delta L by L is equals to alpha delta T is the given formula, right? Is the formula which we know. And alpha value is given and delta T value is also given, right? So 1.2 into 10 power minus 5 into 10. We'll keep as it is this one, because why, you know, like they're asking the force, right? We know that Young's modulus is given as force, that is stress by area. So stress by strain, right? Stress by strain, sorry. Stress by strain is the thing. Young's modulus Y is equals to F by A by delta L by L. We know the value of delta L by L, which we have got from this equation, and we know the value of area also, and we know the value of Young's modulus also. So from this, what we can rewrite, F is equals to Y into delta L by L, and this one A will also go this side, right? So 2 into 10 power 11 into 1.2 into 10 power minus 4 into 40 into 10 power minus 4. So you will get 96 into 10 power 3, right? So we can write this approximately if the option is given 96, we can mark it as it is 96 into 10 power 3, okay. Otherwise, if the option is given in terms of 10 power, okay, 10 powers only, then try to get the value which is near to 96. Near to 96, I can't write 10, I can't write 1000 also, right? 100 is the nearest value, which is 10 power 1 I can't write, 10 power 3 also I can write, 10 power 2 I can write. So 10 power 2 into 10 power 3, which gives 10 power 5 is the value. 10 power 5 Newton is the force, okay. If two such rails fixed at their outer end are in contact at their inner end, a force of this magnitude can easily bend the rails, okay. When I apply this force, it is easily bent, okay. You can take a note of this and we can go for the next. Okay, done. So next question, okay. Show that the coefficient of area expansion delta A by A divided by delta T of a rectangular sheet of a solid is twice its linear expansion. Okay, this is a homework question, you can take it, okay, homework question. So in EAPCET point of view, it is not that much important, but you can take the values, okay. It is 2 times of alpha, that's it, okay. So next question, a blacksmith fixes iron ring on the rim of the wooden wheel of a bullock cart. The diameter of the rim and the iron ring are 5.243 meter and 5.231 meter respectively at 27 degrees Celsius. To what temperature should the ring be heated so as to fit the rim of the wall? Okay, so this is the question, and yeah, sorry, this is how there is a solid 1 minute time. Okay, you can take a 2 minutes time for this question and you can give the answer. Yeah, 1 minute time left out. Okay, so we'll see the answer. Yeah, so when we talk about the alpha value, it is 1.20 into 10 power minus 5 Kelvin inverse, and it has been given L1 and L2 has been given as, okay, so 5.231 and 5.243. okay, so L2 is nothing but L1 times of 1 plus alpha delta T, right. So when we take the values and when we substitute it, we'll get the temperature as 218 degree Celsius, 218 degree Celsius. So whoever got around 200 to 220, that's the answer, okay. That's the answer of this question. Okay, so with this I'll wind up this class of today's session, and in next session now we'll try to do n number of questions on this topics, and we'll go for the next topic. Okay, so thank you guys, we'll meet in the next class.